Please, Mr. Samit.
So thank you very much, Mr. Momen and Fair, for providing the opportunity to share my views.
You're welcome, Mr. Samit.
And I will,
And we would like also to thank you so much, because we reached you at a very short notice.
Catastrophes
thank you so much.
That are common in the African continent, and my focus will be on the underdeveloped markets where CAT modeling can play a greater role. So with this, I start the presentation, the natural catastrophes in Africa and their management. So before I go to the main presentation, a brief introduction about my organization, JB Boda, which is very well known to the most of the audience. But just to have a brief introduction, we are almost an 80-year old company with tremendous ideas to serve our clients. The zeal which took us to the Middle Eastern and African and Asian markets almost 6 decades back is the driving force. We are the only brokers. We were the first Indian broker accredited at Lloyd's, and the only Indian broker with who has experienced the 3 phases of Indian insurance industry. Currently, we handle more than 600 million annual premium, and with 27 offices in India and 10 offices overseas, we try to serve our clients in more than 95 countries. And with this, I come to the main presentation, which is basically the earthquake risk in Africa. So as we can see, the map from the USGS, the African continent is exposed to earthquake risk in 2 parts, mainly on the northeast, in the southeast, and in the northern part. So in the North Africa region, countries like Algeria, Morocco have a relative moderate seismicity, but there have been some events. The repetition of those could be catastrophic. The important ones are listed here. And collectively, these events have caused more than $10 billion economic losses in the past. And with the increase in economic activities, the losses could be catastrophic in future. Coming to the Southeast Africa, we all know that the East African Rift System, which starts from the Red Sea and goes up to Mozambique, is the potential source of seismicity in major countries from Ethiopia, Tanzania, Kenya, Mozambique, Uganda. And it has also experienced some big events as shown in the slide. So these two are the sources of earthquake risk in Africa. From earthquake, now we move to cyclone. The African East Coast is facing the Southwest Indian Ocean, where where the countries are experiencing cyclones on a regular basis. One of the countries that is highly exposed to cyclones is Madagascar. And if you see in this slide, if Madagascar wouldn't be there, the African countries, many African countries would be exposed to cyclones. So Madagascar is kind of protecting the African mainland from the cyclone risk. But there are some, like Cyclone Idai in March 2019, which caused huge damage in Africa. And with the increase of sea surface temperature and global warming, cyclone risk could be more. And the coastal communities from Tanzania to South Africa could experience increased frequency of cyclone, which could be severe, as we have seen. Because if we remember the recent cyclone Shaheen, which started in Bay of Bengal, had heavy rains in India and then regained its strength and hit Oman, and then again caused huge losses. So with the changing pattern, cyclone could be more frequent and more severe, and as a result, not only the property but life and crop risk could also increase. And that's where the insurance companies and the governments and regulators have to step up. This is one of the slides which shows how we can prevent damaging the homes in case of cyclone comes. In Florida in general, people, before leaving their homes, they cover the window openings using the plywoods. Otherwise, when they are constructing new homes, these impact-resistant glasses are used for construction. And as we can see, these impact-resistant glasses can withstand up to 320 kilometers strong wind speed. And then, and thus it saves the building from damage. And now coming to the flood risk in Africa. Flood, not only in Africa, but floods are becoming more common. The flood have two parts, basically the riverine floods and the urban floods. And unfortunately, due to unplanned growth in many parts of the world, and Africa is also Africa is also not an exception. The unplanned urbanization is basically triggering the urban floods in various cities, which is creating problems. For example, floods can damage the critical infrastructure, as the slide shows. During Cyclone Idai in Mozambique, the road network was damaged. And this can happen in any country or territory. But there are ways, as South Africa and Mozambique has shown us the way. The flood risk assessment can be done using the flood hazard maps, which is developed at country levels. And out of Africa, there are other examples where many countries have their own way of assessing the flood using the flood hazard maps. And this is the start. Again, this slide talks about urban flooding, and these are the factors. As you know, global climate change, urbanization, heavy rainfall, encroachments on roads, and improper drainage system, they trigger the urban floods. I would take the example of flash flood in Egypt, and the picture is of April 2018, in which the New Cairo experienced the flash flood. And as we did some research on flash flood in Egypt, we found that the flood events have caused huge economic losses, and they are very common in the Sinai Peninsula, Eastern Desert, and Red Sea Wadis. And they they can create more problems as the population increases and urbanization progresses. So with this comes CAT modeling in picture. CAT modeling is not the ultimate solution, but it's an educated guess which allows one to have an accurate or like a good estimate of loss that can happen. So this is the brief history of evolution of CAT models. In the 19th century, the American and British insurance companies used to manage their risk by mapping the structures. And as during the 20th century, the science helped the human beings to not only compile the data of hazards and also the measure the hazards. It was easier for the scientists and the research community to do the scientific measurement, and with the advent of geographical information system and IT led the development of early models. They were not very sophisticated as they are today, but they were good enough to give them an educated guess.
Mr. Samit, can we conclude in
modeling
5 minutes?
Were established in USA, and these are the dominant firms even today. But the real use of these models started happening after the Hurricane Andrew, which hit Florida in August 1992. And as the insurance companies faced bankruptcy, they started looking at the science and technology to provide them the estimate of the potential losses their exposure could face. And gradually, the insurance and reinsurance companies across the globe realized the importance, and the science of CAT modeling progressed. And now these models cover almost entire globe. And with the increase in economic activities, various CAT modelers are now focusing the model development activities for African countries. Some of them are shown here. For example, CAT Risk Solutions, it's a London-based company that has the earthquake models for various African countries. JBA is a specialist flood modeler that has global flood model, and it can cover, and when the policy and policy data and exposures are given, they can model for any country in the world. CoreLogic, formerly known as, previously known as EquiCat, has models. In fact, they were the first company to develop the CAT models for the African countries, for example, Kenya, South Africa, Mauritius. And most of us, you would remember that RMS, the risk management solutions, as it is commonly known, recently signed a consultative agreement with Tunisia to create an exposure and accumulation study with focus on flood, terrorism, and other natural catastrophes. And lastly, the GEM Foundation offers Africa earthquake hazard risk model. So with this, the modeling capability is available. Thanks to technology, data collection is easier, and these companies also share the data templates and also advise what else is to be captured. For example, age of building, occupancy of building, construction type, number of stories, which are the primary factors for doing the modeling.
Yes. Mr. Samit, can we conclude in 1 minute, please?
Our experience at JB Boda.
You cannot hear me.
JB Boda in India has been carrying out CAT modeling for over a decade for various insurance and reinsurance clients using the prevalent models such as RMS, AIR, and EquiCat. And in 2014, we co-developed the first ever flood model for Sri Lanka in collaboration with an esteemed client in Sri Lanka and a global flood modeling company. Interestingly, we are only a few brokers with the in-house CAT modeling facility for our Indian clients. In addition to the insurance companies, we can also do the retro modeling for the Indian exposure of the reinsurance companies which write the business from Indian market. And we are glad to express that the data quality is significantly improved in India. Now, when we started 15 years back with the launch of India earthquake model by RMS in association with the GIC, the data was collected at state level. Some companies started collecting at district level. Now, most companies are providing it on pin code level, which is allowing the modelers to model the data, and then reinsurers are also having more trust on the company's capability and how their exposure is behaving.
Mr. Samit, if you hear me,
a brief
example. Mr. Samit, can you hear me?
Over time, when the market matures and the more and more companies start getting understanding of how to collect the data is collected at higher resolution. In these pictures, I am showing how the data collection improved in India, and I'm taking the example of GIC's location. If we see on Google Earth, if I give at like state level address, I can see only one point named GIC. But when I give the city level address, it starts taking me to the city of Mumbai, where GIC is located. And then when I give the pin code level information, the more Google Earth starts finding the exact location of GIC. And when the building level data is given, it can find out where GIC is located. And this is how we can come from macro to micro level, and modelers can model at any level, but reinsurers will be happy if the data is provided at building level. And I'm sure in the very soon for various African countries, the companies working in those regions will have the pin code level, pin code or postcode level data, which will give them comfort, not only to know where their exposure is located, but also to control the exposure accumulation, and finally will help them get the suitable reinsurance cover. And this is where the catastrophe risk management strategy in an insurance companies can work. It can be used in underwriting. And as Mr. Joseph suggested, if we have the detailed location level mapping, it will help underwriters to properly analyze risk before the company consider it. They can assess it against various perils, for example, earthquake or flood, and cyclones, volcanic eruptions, and for man-made perils also. And once the data is collected and validated, the CAT models can be run, and which will allow the companies to have the proper reinsurance cover for various perils.
So with Mr. Samit, thank you so much indeed, Mr. Samit.
And my